Hello everyone, it's Witch Calypso and Bubbles again. We're gonna give you another tutorial here for RPG Maker MZ. Once again, you probably use this for MV. It's both JavaScript, so code should be the same. So we have a lock safe here, and we're going to try and open it. So right now, that's just there to show you some of the inner workings of things. Obviously in your game you wouldn't show this here. This is basically telling me what the code is. So 792, but I'm going to put in 709. And you'll see there, it gave me the number back, but it made the 7 a green, the 0 a red, and the 9 yellow. And not quite. So now if we put in the correct one, which is 792, correct, and it opens. So let's look more into the code here and see what exactly is going on. Alright, so first off, let me show you what kind of variables you're gonna need for this. So generally this is, it's a little bit, but it's not that bad. So you want to have a combo guess, and then you want to have variables that equate to how many digits you're using for your code. So mine is 3, so if you want to have 4 or 5, then you just need an extra variable to handle each placement. So if it's 3, then I have a hundreds, a tens, and a ones place. If you have 4, you'll need a thousands, and then for 5, you'll need a 10,000s. So we have these 3 here that are for the combo guess, this one here for the number, this is the actual code, what it is, and then color. And then we have the combo array. And I'm also using RNG. Whenever I make any project in RPG Maker, variable 1 is always my RNG, and it's kind of just like my dump variable. So, combo guess, which is what, if you do input number, this is where we're storing that number into combo guess. So I'm resetting it to 0 here, so that way whenever you try this again, it won't remember the last thing you guessed, it'll reset it back to 0, so you can start fresh. Just convenient for the player. And then RNG equals 3. This is basically counting down how many attempts you have until, the code resets itself. So let me pull up this code here. So, this is a temporary array, numpad, equals to 0 to 9. Basically the numbers that you would see on a normal number pad. Code spot equals 25. The 25 equates to here, these number here. The variables are monitoring what the actual code is. So we set code spot equal to 25, and then we have a while loop. The while loop, code spot, as long as code spot is less than 28, because we want it to go through each position. So we want it to go through the hundreds, the tens, and the ones, which is variable 25, 26, and 27. When it gets to 28, it'll get out of the loop. X equals numpad.length, which once again is getting the length of the numpad array, which will return 10. I equals math.randomInt, and then we are inputting X for the length, so we know what numbers are available for the length of the array that it can grab from. And then GameVariables.setValue of CodeSpot, which is variable 25, then 26, then 27, equal to numpad at that index that it grabbed here for the random number. And then we splice that number out of the array because I don't want the code to have duplicate numbers. So I don't want the code to be like 909. You can do that if you want, you just don't put in the splice. I just feel like for the context of this puzzle, that can make it more difficult. So I think it just is better to have it be one number each number can only be used once. And then code spot ++, this just increases the number by 1. And then after we have that set up, we set game variable 31 equal to numpad. The reason why we're doing this is, I'll explain this later, but if you remember, 31 is like saving what is left of this array. We'll come back to that later. And of course, this here is just what I showed before, where this is just telling us basically what the code is. The first variable here is like what is left of the array, and the one down here are, you know, the actual code. So in your game, you wouldn't have this. This is mainly here for testing purposes. And then we're gonna have a loop. And I have two things here. If RNG does not equal 3, so if it's your first guess, we're just gonna show this down here, which is what is the combination. We're not going to show the previous guess because the player hasn't guessed anything before. Sorry, there you go. So this basically, it's just a tiny thing. You don't really need to do this if you don't want to, but it's just another convenience for the player. And honestly, you don't even have to like split it up. If you want to just say previous guess 000 to let the player know that they didn't guess anything before, that's also fine. This is just like, you know, tiny little details. But yeah, so this is just going to be here if it's past your first guess to let the player know what their previous guess was and what color coordination. Oh, sorry, you can't see that. Sorry. What color combination you got for your previous guess, just as a reminder so they don't have to memorize it. So once again, input number is self-explanatory. You're inputting a number. And then let's look at this code. So guess is going to equal variable 21, which is where the input number is being stored. So this is just being aware of what it is. So for us to compare these numbers, because down here, we're essentially comparing what you guessed in the hundredths place and what the game has for the hundredths place, and we're coloring it either green, yellow, or red. If it's green, that means that it's correct. If it's yellow, that means that it's the correct number, but it's in the wrong position. And then if it's red, that's just telling that this number is not in the combination at all. But to do that, we have to break down the guess into its hundreds, tens, and ones place. And we do that by using both division and modulo. To explain, obviously, I assume you all know how division works. You take a number and then you divide it by another number to get arguably a smaller number. Basically just saying, how many times can this number go into this number? So 10 or 100 divided by 10 would give you, well, 10, because 10 can go into 100 10 times. Basic algebra. Modulo is kind of the other side of that coin, where it gives you the remainder. And I guess to put it this way, in RPG Maker, it doesn't give you decimals. It'll always truncate or round down the number that is given. So if you do 5 divided by 2, technically that equals 2.5. But RPG Maker is just going to make it 2. But if you did modulo, then it's going to give you the remainder of that. So 5 modulo 2, 2 can only go into 5 2 times, but you're left with a remainder of 1, so it would give you back 1. So by breaking down your 3-digit number, we're gonna get the hundreds, tens, and ones place. We do that by taking guess, and then we divide guess by 100. By doing division by 100, so let's say our number was 578. If we do guess divided by 100, it's going to return 5, because that's how many times 100 can go into 578, and it drops the 78 because that's the remainder. To get the tens place, we're going to use modulo. By doing guess modulo 100, it's going to give us the remainder of that number, which would be 78. And then we divide 78 by 10, and that gives us 7. So now we know what the tens place is. And then for the ones place, we're going to use modulo 2 times. Modulo by 100, and then modulo by 10, and that will give us essentially the remainder of 8. And so now we have these numbers broken down. We have our hundreds place, we have our tens place, and we have our ones place. Definitely look more into modulo. I know it's like Modulo is the one operation that is like used the least, and there's not really much. You don't really use it in your day to day. But it is a really cool function, so definitely look more into it. It's a way that you can, for example, RPG Maker does store gameplay time, and you can store that into a variable. And by using modulo in Division, you can once again break down that time frame, so you can show the player how long they've been playing, but in actual like hours, minutes, and seconds, as opposed to just like one number that's just showing seconds. So you can do stuff like that. And then we do count equals 22, because now we need to compare. So count equals 22 because we need to compare your number to the actual number. And so we do that with an if-else if. So the first if here is taking game variables.value of count, which is right now variable 22, and then is it equal to count plus 3. So you can, this is something cool you can do, where you can have the variable in here. So it would be 22 plus 3, which gives us 25, because the 25th variable, here, let me show you, give it better, proper visual here. This is also a reason why you want to make sure that you put these in like order. You want to have these in like a proper order so this works. So your guess is here. So and the actual number is here. So we do this plus 3 because this is 3 apart. And as it goes through the while loop and is checking each position, it's going to be that number plus 3. 23 plus 3 is 26. 24 plus 3 is 27. Let's go back here. Okay, so right here, and then of course we do count plus 6 because count plus 6 is for the color, because we want to get the to tell the player if they got something right, wrong, or if it's right but in the wrong place. We need to color code it, and so we need a variable to keep track of the color so we can, you know, do the color coordination, which is plus 6. And so once again, this is why you want to make sure that these are in like order. So if you want to do a combination that's like 4 digits or 5 digits, you want to make sure you set up your variables properly for that. And even if it's like later on in your game you want a harder combination, just keep that in mind and make sure you have proper spacing for everything. So sorry, let me go back here. If the value of your hundreds place is equal to the actual hundreds place, then we're gonna set the color variable equal to 11, because in the color wheel, I mean, I can show that here. We go to text. So in the color index on this thing, 8 is green. Or sorry, I said 8. Why did I say 8? 11. 11 is green. On that. So this is green, 18 is red, and 17 is a yellow. But yeah, so this first one's pretty simple and self-explanatory. It's just checking to make sure and see if your guess is equal to the actual number. The second one here, we're doing dot includes. This is another feature or function you can call for arrays. And basically it does what it says. It's checking game variables.value of 31, which, as you remember, this is where we saved, variable 31 is where we saved the remainder of numpad. Basically, these numbers were not used in the code. So here, we're saying if the number that you're guessing, if it's included in that array, then we're gonna make the color 18, which is red. Basically saying, this number you guessed is in this array, which means that this is not in the combination, so it's red. Otherwise, the only other thing it can be else is yellow, so we just make it yellow. And then we increment count, which goes through, once again, the hundreds, tens, and ones variables. And then every time that you get one correct, we have this variable here, correct, which we establish here to equal 0. So if you get 3 correct, then it's going to turn on game switch's value of 1, which is unlocked, equal to true. Go down here. Once again, this is by combining the color and variable thing, control characters, so to say, by putting these, or nesting it inside of it, we can tell it to give it a number, and then that number will then be the color that it shows. So what we were doing before, right? And then it shows variable 22, 23, and 24. So if you do it correctly, if you follow this, then if you do it correctly, then these will be, it'll show the number you guessed, and then whether it's green, correct, yellow, correct but in the wrong spot, or red, just not in the combination. Okay. And then if the switch is on, combo unlock is on, then it's correct. And then it turns cell switch A on, which basically just opens the safe. And this is where you would obviously code it into where the player gets money or an item or whatever, right? Or it activates a switch or, you know, something else, you know? It opened the door. Go wild, you know? Your imagination, let it go wild. And then we turn combo unlocked off. The reason why is because if you have more of these, then you want to make sure that you turn the switch off. So if, sorry, I'm going in circles, but yeah, you turn it off so that if you're going to use this again, you don't have to make multiple switches. You just need the one switch for this kind of puzzle, and then you break out of the loop because we aren't in a for loop here. But if you get the combination correct, it breaks out of the loop. And then otherwise, we're going to subtract RNG by 1. And then as long as RNG does not equal 0, that means you have more guesses. And so it plays buzzer, not quite, tells you how many guesses you have left. And then it loops back up to the top here, and you get it asks you what the combination is once again. If you run out of guesses, so RNG equals 0, then the code is going to be reset and try again, and we break out of the loop. So that way, if the player interacts with this once again, it goes through this process again and gives you a new code, and you start anew once more. So here, let me show it to you once again. So once again, we know the code is 976. So if I do it once again, we do 9, and then 0 and 7. The 9 is green, because that is correct. The 7 is yellow, which means that is the correct number, but it's in the wrong position. And then the 0 is red, because that's just not in the combination. And so if we move it over here, we do 7, and we do like, 4, let's just do 4. Now the 9 is green, the 7 is green, but the 4 is red, meaning once again, that's correct, that's just not in the combination. And we have one final guess, so we're gonna make the 6, and it's correct, and the safe opens. So there you go, that's a cool little puzzle you can do. So that's all I have for today. Go wild with it, there's many applications you can use for this, and once again, if you want to have there be more digits in the combination, you just add more variables, but it's the same process. So thank you guys so much. Let me know if you have any questions, comments, or concerns, or anything else you want me to kind of try and explain in the tutorial. But until next time, y'all have a good one. Bye!